So today's lesson is Unit 2, Lesson 13. And we're going back a little now that we've reviewed how to graph lines. And so I feel that we're ready for this additional method of solving a system of equation. So this is in our Unit 2 book, right? So the book we've been using all along, page 244. So I'll give you a minute to get to that. Right. So we've previously talked about how to solve system of equations, right, by graphing. So a system of equation is two or more equations, right? We're finding a point that's on both lines. So in other words, a value for x and y that satisfies both equations. So where they meet, right? Where do these two lines meet? The point at which they meet is the solution. That's what we spoke about previously. There are other ways to solve systems of equations. Substitution is one, and elimination is another. And for the next couple lessons, we're going to talk about substitution. Now, substitution is just like it sounds. When you find a substitute for a teacher, someone is in her place, right? Same when you're substituting an item on a menu, right? So for substitution, we're going to find values for variables, okay, that we can use in its place. But before we do that, let's use what we learned about graphing lines to help us reason about this problem right here. So take a minute to read it, and then we'll discuss. So it says, here are graphs of two equations in a system, right? So that's a line, the blue line. This is another line. Determine if each of these systems could be represented by the graphs. Okay, be prepared to explain how you know. So these systems right here. So this is a separate question, right? So this is 4 separate questions. It's not multiple choice either. It's just a matter of you don't know for sure that these are the systems because there are no numbers, but based on what you know about what these lines should look like, could these possibly be them? So let's look at what we know. We know this line has a negative slope. And you know that because it's trending downwards. You know this line is x equals something, and it's a positive number, and you know that because it's to the right of 0, right? And you know that the y-intercept of this line is also a positive number, right? So you know quite a lot just by looking at the shape of that graph. All right, so in order for this to be possibly represented by the graphs, for these equations to be represented by the graphs, you would have to, both of them would have to be possibilities, right? Not just one. So when I look at the first one, x plus 2y equals 8, right? It's not in the form y equals mx plus b. There's something for me to unpack. So I'm just going to go to the second one and see if I can figure that one out, since that looks a little easier. When I look at this graph, I notice that it says x is equal to negative 5. So it's a vertical line, that's true, but negative 5 would be to the left of 0, right? So that line would be somewhere here, negative 5. So this is not a possible representation of that graph. All right, let's look at the second example. So slope-intercept form, the first one, it has a negative slope. Good, we talked about that. -7 is the slope. It has a positive y-intercept. Spoke about that. Now let's look at the second one, y equals -1. The line y equals -1 is a horizontal line at -1, right, on the y-axis. So no, that's not a possibility. All right, let's look at the third one. It says 3x is equal to 8. Right? So this is, if 3x is equal to 8, then this is the graph of x equal 8/3. That's a positive vertical line, so that's possible, sure. Let's look at the second one. All right, so I'm going to put it in slope-intercept form so that I can judge whether or not this is going to be, so that's -3x plus 15. So a positive y-intercept and negative slope. This meets all the requirements. So that is a yes. All right. Let's talk about the next one. It says y equals 2x minus 7. Okay. So this is a positive slope, which we know is not the case, and a negative intercept. So right then and there, this is a no. Right? If you chose to look at the second one, this would give you y equals 8. Y equals 8 would be a horizontal line. Okay, so that would not, this graph would not represent that system. All right, so let's talk now about how we could solve these systems using substitution. All right, now prior to this, we would have done this by graphing, right? And that's one way. Substitution is a method that's best used when you can isolate one of the variables, right? Or even if you don't know the exact number, but you're able to find a value that's easily substituted. So let's look at the examples. So the first one is x plus 2y is equal to 8. The problem with solving that equation by itself is that it has two variables, right? So you're not going to be able to find a number, find a number for one variable, right? You may be able to rewrite the equation and find one variable in terms of the other, but you're not going to find a numerical value. So in order to do that, you need to somehow rewrite this equation, right? And if you look, you have x equals -5. So that helps because this means that in place of x, I can put -5. Because remember, x and y has to be the same or have to be the same value in both equations. So I'm putting parentheses, not because it means multiplication necessarily, but because I'm showing you that that's what I'm replacing. Right? So now I need to solve this equation. So I'm going to need to add 5 to both sides. So that gives me 2y equals 13. Right? Now I'm going to have to divide by 2, y equals 7.5. So if we were to graph that system of equation, what this means is that the point at which these two lines would meet is -5, and that's because it's the x value. Remember, ordered pair. Okay, so the order matters. And then 7.5 for the y. So that's where they would meet. Now to check, right? You could check, of course, right? Now it's relatively easy to check by graphing since you have the graphing technology to do that relatively quickly. But I'm going to show you how to check algebraically. So to check, you need to substitute the value for x and y into both equations to make sure that they yield true equations. Now, x equals -5. Well, no need to do that because it literally tells you x is -5. So we lucked out there. But let's replace x and y in the top one. So x is supposed to be -5 plus 2 times y is supposed to be 7.5. And those together are supposed to give you 8. All right. So let's check. All right. -5 plus 2 times 7.5. What does that give you? What did I do wrong? Oh, I see my mistake. My calculation error, right? And so this is why it's important to check. 13, right, divided by 2 is not 7.5. Miss Hazel had a moment. It's 6.5, right? So you're probably at home screaming, no, it's not. All right. So that would be 6.5. And then this is supposed to be 6.5. So let's check it now, see if it works. All right. So -5 plus 2 times 6.5. And there we go, right? That's -5 plus 13. It works. So I know I'm correct. All right. Let's try number 2. So you know that y is equal to -7 plus 13. You also know that y is also equal to -1, right? You need to rewrite one of the equations so you only have one type of variable to solve for. So here, if y is -1 in the second equation, then y is also -1 in the first. So I'm just going to replace, right, my y with -1 in the first equation. I'm sorry, that's a plus 13. Okay, so now it's -13 minus 13. So -7x is equal to -14. Divide by -7, divide by -7. X is equal to 2. Right? So if you were to graph these two lines would intersect at the point 2 because x is 2 and -1 because y is -1. All right, now let's check our answers. Okay, so if you're checking, right, no need to, this equation is pretty self-explanatory, but the first one, if we're told y is -1, okay, and then -7 times x, which we're told is 2 plus 13, right? -7 times 2 is -14 plus 13. That gives you negative 1. So that side gives you negative 1. And we already know this is negative 1. So that's correct. All right. Let's look at the third problem. Alrighty, so 3x is equal to 8. 3x plus y is equal to 15. Now, we've spoken about isolating the variable, and you could certainly, we already knew, right? We knew from the system above when we worked it out that x is 8/3, right? We knew that. So we know x is 8/3. But think about what the goal is. Don't just automatically isolate a variable. Do you have what you need to substitute without isolating? And this is, think about it. If 3x is equal to 8 in the first equation, then it's pretty handy dandy that 3x must also be equal to 8 in the second equation. So instead of going ahead and isolating x and then multiplying it by 3, right, you could simply replace 3x with 8 because 3x is literally 8. Okay? So then you minus 8, minus 8. So y is equal to 7. Alrighty, so now if we were to graph these, right, they would meet at 8/3 and 7. Let's check. All right, so first one, 3 times 8/3. Does that give you 8? Yes, it does. Okay, second one. Remember, you have to do it in both equations. So 3 times 8/3 plus y 7 should be 15, right? Is that the case? So 3 times 8/3 we already determined it's 8. 8 plus 7 is 15. So both these sides are equal, so this equation is true. And our last one. So you know y is equal to 2x minus 7. You also know that 4 plus y is equal to 8. So you don't have a variable by itself, and you don't have something that's easily substituted. But what you could do, you could easily, right, figure out what y is using the second equation. So y is 8, right? So if y is 8, we could go ahead and substitute our 8 there. So I'm left with 8 equals 2x minus 7. Okay. So add 7, 2x equals 15, divide by 2, x equals 7.5. So if we were to go ahead and graph these, the lines would intersect at 7.5, 8. Okay, let's check. So y is 8. So 8 should be equal to 2 times 7.5 minus 7. 2 times 7.5 is 15. 15 minus 7, we already know, is 8. Right? So this first one is true. For the second one, easy peasy. 4 plus 8, is that 12? Sure is. So we know we're correct. So you should always check, right? All right, let's look at some of these. 13.3, right? I'm not going to record all of them, but I will record number 1, right? And the notes with the answers will be available online. So let's look at number 1. Number 1 is different, 13.3, different from 13.2 in that you don't have a numerical value for one of the variables, right? But, right, you simply have the variable rewritten in terms of one of the others. But that's okay. That's all we need, because then that gives you the opportunity to have an equation with just one variable. So we know x is y plus 4. Okay? So therefore, wherever we see x in its place, we can put y plus 4. So 5 times, let me write a little smaller. Okay. So 5 times y plus 4, okay, minus 2y equals 26. All right, so I just replaced x with the value of x, which is whatever y is plus 4. So now we have 5y plus 20 minus 2y equals 26. To solve this equation, you're going to need to combine like terms since they're on the same side. So 5y minus 2y is 3y plus 20 equals 26. Now to solve this equation, subtract 20, subtract 20, 3y equals 6. To find y, you're going to need to divide by 3, divide by 3. Y is equal to 2. All right, so y is 2. So now that you know what y is, you're going to need to substitute. And I'm going to substitute in the second one since that seems so much easier, right? So that I can find x. So y is 2. 2 plus 4 is x. That means x must be 6. So if these two, right, if these two lines were graphed, the point at which they would intersect on the coordinate plane would be 6, 2. Okay? Let's check our answers. And I'm going to check it on the calculator. So we said x is 6, y is 2. So it should be correct for both equations. Right? So that means if x is 6, so 5 times 6, right, minus 2 times 2 is 26. And look at that. It is 26. And then, of course, we already did the second one down here, right? When we found 6, right? So 2 plus 4 is 6. So that is correct. So this is as far as we got in class, right? What you should do now is complete assignment number 13. So you can look for that in our module. And so this is week 2, the second quarter. So look for assignment 13, complete, take a photograph, submit. And then on Wednesday, we'll have another video where we continue practicing these kinds of problems.